Hi students, I thought I would try to help you out with finding the zeros, so I typed up some notes. Our goal is to find all of the factors of the polynomial. Then from the factors, we will find the roots, aka the zeros, the x-intercepts, or the solutions. Find all of the roots or the x-intercepts of. So here's our problem, and we're going to do this without a graphing calculator. So where do we start? We start by making a list of possible rational, which means fractional, zeros. This is called using the rational zero theorem. Write your constant over your leading coefficient like this. Our constant is 3. Our leading coefficient is 1. So we're going to put our constant, which is 3, over our leading coefficient, which is 1. Then list all of the numbers that multiply together to give you 3. Those are called the factors of 3. So that would be positive and negative 1, positive and negative 3. We do the same for the denominator, all the numbers or the factors of 1. So positive 1 times positive 1 or negative 1 times negative 1. So we did that. Then we match every number in the numerator with every number in the denominator. So in other words, 1 over 1, which is 1, and 3 over 1, which is 3. We get used to putting plus or minus in front. So these are the possible rational zeros. Rational just means fractional. 1 is 1 over 1, therefore 1 is fractional. 3 is 3 over 1, therefore 3 is fractional or rational. These are the only numbers that we will even check in synthetic division. These are the only numbers we will try. So here we go. We're looking for a remainder of 0. Let's try positive 1. So remember, we bring down the coefficients only. So let me go back to the original problem right here. We go back to the coefficients only, and if there are any missing powers, we'll always put a 0 in for a missing power or a missing constant. So we have 1 from the 1x cubed, negative 3 from the negative 3x squared, negative 1 from the negative 1x, and positive 3 from the constant. So we bring down the 1. 1 times 1 is 1, add, and we get negative 2. 1 times negative 2 is negative 2, add, and we get negative 3. 1 times negative 3 is negative 3, add, and we get remainder 0. Once you find the 0, factor the depressed equation. So this is called the depressed equation. And it's called a depressed equation because the original equation started out 1x cubed. You see up here, the original equation started out 1x cubed, and the depressed equation will start out 1x squared, and then minus 2x, and then minus 3. So we set our depressed equation equal to 0, and we factor. So we'll factor this. So we have x and x gives you the x squared, two numbers that add together to give you, two numbers that multiply together to give you negative 3, add together to give you negative 2. So that would be a negative 3 times a positive 1. They multiply together to give you negative 3, but they add together to give you negative 2. So these are the factors. X minus 3 is a factor, and x plus 1 is a factor. So to find the zeros, we set our factors equal to 0, and we solve for x. So here we would add 3 to both sides, so we get x equals 3. Here we would minus 1 from both sides, and we would get x equals -1. So the zeros are +3, -1, and +1, the one we found using synthetic division. So +1, +3, and -1. Those are the zeros. If I wanted the factorization, the complete factorization of the polynomial, the factors, in other words, the factors are x minus 3, x plus 1. Remember, we got those when we factored. And if +1 is one of the zeros, the factor is x minus 1. Okay? Let's say we wanted to sketch a graph. It doesn't have to be perfect, just sketch a graph. We know that the 3 zeros are +1, -1, and +3. I know that the graph has x-intercepts, these 3 places. So here's the original function again in standard form. We know from this term, from our 1x cubed, we know that our leading coefficient is positive, which means our graph will be rising on the right side. We know if our degree is odd, we know the arrows have to go in opposite directions, odd, opposite. So that means the arrow on the left has to be going down. So a graph will pass through. It'll pass through one of the zeros and then turn. It'll head toward the next zero. It'll pass through and turn and head to the third and last zero. All right, and that's an example. That's the big picture. That's really everything we want to be doing with this problem. All right, you guys have a great day.